Hello friends, we start with our next topic, that is known as superposition theorem. Up to this theorem we have already completed Thevenin's, Norton's and maximum power transfer. I think you have gone through my all videos and one can easily able to understand the concepts of Thevenin, Norton's and maximum power transfer theorem. Okay, so all those three theorems are very important and you can easily able to understand the concepts through the problem which I have already solved in my previous videos. Okay, so if you really find my all those videos very helpful to you and one can help you to go through your problem solving sessions, especially in competitive examination, please subscribe my channel, please like my channel and please share to your all the friends. Okay, so because once you subscribe it will be more easy for you to go through my all videos. Okay, so now we start with our next theorem, that is known as superposition theorem. We'll understand what is the concept of superposition theorem. Okay, so first of all we'll see that there is a network. This is your network which is consist of various elements and for the time being I am just considering here as two sources. Say this is source 1, say this is source 2. Okay, in this network may be consist of some elements. Okay, this network consists of elements. So this S1 is known as source 1 and this S2 is known as source 2. Now this source 1 and source 2 may be a current source also, it may be a voltage source also, this also may be a current source, maybe a voltage source. Okay, so what superposition theorem states that if there are number of sources present in the network and if you have to find any voltage across the element or the current through the element in this network with the help of these sources, what you will do, you will find their voltage or current one by one by considering one source at a time, and finally at the end you add all the values to get the final value of voltage across the element or current through the element. So I am just reading the statement of superposition theorem. Please try to listen it properly. Okay, so what superposition theorem states that in a multi-source complex network consisting of linear bilateral element, the voltage across or current through any element is equal to sum of individual voltage and current produced independently by each source acting independently. Okay, so this is all about the statement of superposition theorem. You can go through your textbooks also just to understand that statement. However, we will focus here how the superposition theorem is applicable in networks just to solve it. Okay, so as I said, there are few important points, like first, just now I read it like linear, then I said bilateral. So superposition theorem is only applicable for linear and bilateral network. We have already studied about linear network, we have already studied about bilateral network. So whenever there is a linear network or a bilateral network, the superposition theorem is applicable. If you talk about the linearity, the third point comes to be linear network may be of two type. It is time variant or it is time invariant. Okay, time invariant. So in this condition also the superposition theorem is applicable. The fourth one is superposition theorem is applicable for AC as well as DC circuits. Very important, don't confuse, it is applicable for AC as well as DC circuits. Okay, dependent source and independent source, dependent source and independent source. Just keep in your mind these points because you will find the questions in your examination in which they ask superposition theorem is applicable for only linear element, only bilateral element, linear bilateral with time variant and time invariant property. So like that, there are the type of question which generally used to be asked in your competitive examination. So that's why I am giving here just a kind of bullet points just to understand the superposition theorem is applicable for linear, bilateral, time variant, time invariant, AC and DC circuits, dependent and independent sources. And what more? Okay, voltage and current. So this is all bullet points under which superposition theorem is applicable. Now the question is superposition theorem. The point is not question, the point is superposition theorem is not applicable for power analysis. Okay, if you have to find the power, then superposition theorem is not applicable. Why? Because power is basically a square function of voltage and current. Okay, you know power P is what? It is either I square R, or you can say V square by R. Okay, so that's why superposition theorem is not applicable for finding out the power in a circuit. So just keep in your mind, so these are the bullet points under which superposition theorem is applicable and not applicable. Okay, so what we'll do, we will understand the concept of superposition using few problems. Okay, so we'll see the problem under this session. Okay, so friend, this is one problem in which you have to find the value of VAB using superposition theorem. Okay, you have to find the value of VAB using superposition theorem. So now we will understand how the superposition theorem is applicable. Okay, as I said, whenever you are going for finding out the value of whatever VAB or current, voltage or current in a network, please focus on your independent sources. Okay, your dependent sources will remain as it is in a network. Okay, so there are two conditions. One is dependent source and another one is independent source. I have just taken this problem in which we have considered all, that is dependent source as well as independent source. So whenever there is a dependent source, it remains, you can write it here, it remains as it is. Okay, whatever the dependent source present in the network remains as it is, or you can say the condition of those dependent source again depends upon the source condition. Okay, since it is a dependent source, definitely its dependency is somewhere in the network. So again the property of this source basically depend upon the dependency which is mentioned in the network. Okay, now if you talk about the independent source, again there are two conditions, either there is a voltage source or there is a current source. Okay, I write it as CS. So this is your voltage source and this is your current source. So if you talk about the voltage source, as we have already seen, voltage source, whenever you are considering current source in a network, suppressing all voltage source, so your voltage source gets short circuited, and when you are talking about the current source, it gets open circuited. Okay, again very important thing, just keep in mind. Okay, so we will see through this problem. So in this question there are two, this is 1 and this is 2 independent sources, and this is 3 which is a dependent source. So as I said, your dependent source remains as it is, and we'll consider the concept of independent source. So first we will consider that voltage source is present. This is our voltage source, so this is our condition first. Okay, this is our condition first, in which voltage source remains. If voltage source remains, it means rest all the sources will goes off depending upon the condition of sources. Okay, whether there are n number of voltage source or whether there are n number of current source, all goes off. Okay, so in this condition, this is your voltage source, this is your 4 volt. Okay, this is 10 ohm resistance, this is your VAB plus minus 3 VAB, and this current source will get off or it become open circuit. As I said, current source will get open circuited, and here it is VAB. Now this VAB is because of presence of this voltage source, so I write here as 4V. Just to understand, I write here as 4V. Okay, so the value of VAB 4V is because of presence of 4 volt source. Now we will see how we find it. Okay, so now please see, this is an entire network. Now entire it is an open circuit, so no current will flow. Can you directly apply one loop and find the value of VAB because of 4 volt source? Yes, so I am just applying one loop. So I can write here it is minus 2 plus VAB 4 volt. Okay, again minus 2 plus 3 VAB 4 volt, that is or you can say it is minus of 4 volt, that is equal to 0. Why? Because there is no current in 10 ohm resistance because of open circuit. So from here 4 of VAB 4 volt is equal to what? 4, or you can say VAB 4 volt is 1 volt. That means the value of VAB 4, VAB 4 volt is 1 volt. That means the value of this VAB because of presence of this 4 volt is what? It is 1 volt. This is our first condition. Okay, now we will consider our next condition. This is our next condition. Now you see, in next condition we are suppressing this voltage source and we will find because of current source. So this get short circuited. Okay, this is your 10 ohm resistance. Again this is your current source. Now here VAB you have to find because of 2 ampere current source, so I write here it as 2 ampere, just to understand the problem. So what happens, this 2 ampere will flow here in this manner. Okay, so can we apply a super mesh? Yes, so by applying super mesh, it is what? VAB 2 ampere minus 2 plus of 3 VAB 2 ampere. This 2 ampere because of the presence of 2 ampere current source. Now there is no voltage source, it is equal to 10 into 2. So how much it is? 4 VAB because of 2 is 20, or you can say VAB, that is voltage because of 2 ampere current source, is 5 volt. Okay, so this VAB2 is 5 volt. Very simple. Now superposition states that VAB voltage, the voltage VAB in a network is basically because of 4 volt plus VAB because of 2 ampere. Why? Because there are 2 sources. So from here you can directly write it as 1 plus of 5, so that comes to be 6 volt. So this is your VAB. Okay, this is your VAB 6 volt. So from here one important thing, here from this question, one important thing is superposition basically state that in any network, if you have to find say voltage V or you have to find current I, so this voltage V is because of the number of current source or the number of voltage source present within the network. Okay, so I can write here it as because of okay, if you have to find voltage V or you have to find current I, so I can say it is because of say source 1, say source 2, say source 3 or up to dash 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 n number of sources present, that is voltage. Similarly, you can write it as IS1, IS2 plus IS3 plus up to dash 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 ISN. Okay, so this is all about the statement of a superposition theorem. So now your question is whether whatever we have find the voltage VAB here is true or not. So we will directly apply here. Now you see, we will directly apply the concept here and one can find, see this is your VAB, this 2 ampere will enter here, we will apply one super mesh here. So what it is? It comes to be VAB plus of 3 VAB minus of 4, that is equal to 10 into 2, so that comes to be 4 VAB is equal to 20 plus 4, so here VAB comes to be 24, 4, that comes to be 6 volt. So whatever VAB we have find here because of 4 volt and 2 ampere is okay because, when we have considered both the source in the network. So just we have proved also that yes, this is the way to find the value of VAB. Okay, so superposition theorem is just a theoretical and just to understand the network by considering one source at a time. Okay, or you can say simultaneously you can consider the sources and finally you can find the value of voltage or current. We will see one more problem under this theorem and then we will see one more problem. Okay. So this is next problem. In this problem you have to find the value of V naught using superposition theorem. Okay. So from here you can say that the value of V naught is what? It is basically because of presence of 9 volt source, or you can say basically the value of V naught presence of 3 volt source. Yes, you can say the value of V naught is what? Either basically presence of 9 volt source and then 3 volt source. So one by one we will consider, first we will consider the 9 volt source, so your other source will get short circuited. Why? Because it is a voltage source. So let condition 1, let us take condition 1. So how much it is? So this source get short circuited and finally we will consider because of 9 volt source. So simple, you can find, how you will find? Just by applying a KCL at this node, one can get the answer. So I am just applying, it is V naught 9 volt upon what? 9 plus V naught 9 volt upon 1, or you can say 9 parallel 1 combination, plus of V naught 9 volt minus of 9 upon 3, that is what? 0. Okay, V naught minus of 9 upon 3 is the current. Okay, just multiplied by 9 and get the answer. It is V naught 9 volt plus of 9 V naught 9 volt plus of 3 V naught 9 volt, and that is equal to, I can directly write as 27. Okay, so how much it is? 10, 13. The 13 of V naught 9 volt is what? It is 27. So V naught of 9 volt is how much? It is 27 by 13 volt. This is our first value because of presence of 9 volt source. Okay. Now we will see our value of V naught because of presence of 3 volt source. Okay. So now this source will get short circuited. Okay. Now you have to find the value of V naught because of 3 volt source. Simply will apply one this 3 ohm resistance and this 9 ohm is in parallel. I will just find the parallel combination of 9 parallel 3. So that comes to be 9 3 upon 12. Okay. This is 4. So that comes to be 9 by 4. Okay. So this is the parallel combination. Okay. So I can just remove this. Okay. Simple. This resistance will change to how much? It is 9 by 4 ohms. Okay. I am applying one KCL, that is V naught because of 3 volt source is what? It is 9 by 4 plus of V naught 3 volt minus of 3 divided by 1, that is what? 0. Okay. So you can say it is 4 V naught because of 3 volt source plus 9 V naught because of 3 volt source is equal to 27. Or how much it is? V naught because of 3 volt source is again it is 27 by 13. Okay. So we have just find the value of V naught 3 volt and that value also comes to be how much? It is 27 by 30. It is what? 27 by 13. So here the value also comes to be 27 by 13. So finally what is your answer? So your answer comes to be that is 54 by 13 volt. This is the value of V naught. Okay. Here you can see. So that value comes to be 4.15 volt. So this is the value of V naught. Now we will just cross verify this whether whatever we have done is correct or not. So that we also see here. Now in this network I am directly applying. Please see, it is V naught by 9 plus V naught minus 9 upon 3 plus V naught minus of 3 upon 1 is 0. So it comes to be V naught just multiplied by 9. So it is 3 V naught minus of 27 plus of 9 V naught minus of 27 is 0. So that comes to be how much? It is 14, not 14, it is 13 of V naught is equal to 54, or you can say V naught is what? 54 by 13, that comes to be 4.15 volt. Okay. So with this you understand, just by considering one source at a time you can find the voltage, and finally just by adding all those voltages one can get the value of V naught. So this is just a concept, theoretical concept. You will not see problem in your competitive examination through this topic, but however in engineering services and conventional paper such type of question may sometime ask. Okay. So this is all about the superposition theorem. Okay.